So following on from the previous video, I'm now going to show you how to integrate this the long-winded way. But it's long-winded, but it will give you a better insight of what's going on. And also in the future, this won't be nice and simple. So to integrate this, your eyes should zoom into this bit here, and then create a right-angled triangle in such a way that this thing here will be true. You see, if you make this to be 2 and this to be x, then the adjacent here will have no choice but to be 4 minus x squared. So that's this 4 minus x squared here. So now if you look at this, remember we're trying to replace this, and then we are trying to replace this. So somehow try to isolate this thing here. So if you look at this, cos the angle. So cos the angle will be adjacent over hypotenuse times both sides by 2. So that will then give you this. And now differentiate both sides. So differentiate this and then differentiate this. That will then give you this thing here. And then tidy this up. Tidy this thing up. It will then give you this. Now, if you look at this here, going back to this diagram, this thing here is actually 2 cos theta. So if you look at this here, this thing here is actually 2 cos theta. That's this bit here. And then if you look at x, going back to the diagram, x is that thing. If you look at the diagram, sine of the angle is x over 2. Now times this, so x is really 2 sine theta. So going back to here, we can replace x with 2 sine theta. Now this would then cancel out. Hang on. This would then cancel out, and then that would then give you this, and then times cos. That will then give you this. Now we've got dx. So if you look back right from the start, we were trying to integrate this here. We now have dx, so we can put this into the dx, and this complicated thing here we can replace that with 2 cos theta. We can replace that with 2 cos theta. So this whole thing here will then become this. So that there is just 1. So integrate 1 will give you theta. So the answer here is theta. But we don't want the answer in terms of theta. We want it in terms of y, in terms of x. So going back to here, we want so the answer is theta. But we don't want the answer in terms of theta. We want it in terms of x. So if you look at this here, inverse cos equally to both sides, then you're going to have this inverse cos of this whole thing here, root 4 minus x squared over 2. So theta, so to integrate this, it would be this, but rather than using this, so the answer is theta. But rather than using this cos thing, we should use sine. It's nice and simple. So if you look at this, sine theta equals x over 2. So if you want theta on its own, then theta will be inverse sine of x over 2. So when we got to here, the answer is theta. We could use this, or we could use this, but let's use this. It's much simpler than this. So the answer here is theta. So to integrate this, it will be this thing here. So hang on. So to work out this whole area here, our normal routine would be to integrate it from 0 to an arbitrary point b, and then later on let b move towards 2. So this has so our normal routine has always been to integrate it from 0 to an arbitrary point b, and then later on we will take the limit as b tends towards 2 from the left hand side. But then rather than doing that, I'm just going to skip it and just do it from 0 to 2 from the left hand side. So from here, that will then take us to here. So So in the past, we would integrate it from 0 to b, and then take the limit as b tends to 2 from the left hand side. But rather than doing this, I'm just going to say integrate it from 0 to 2, and then with this negative symbol here. Okay, so that will then give us this, and then evaluate this thing here. The area will be pi over 2. So this area here is pi over 2. Okay.